What if you traveled to the Permian period? Imagine stepping into a time machine and traveling nearly 300 million years into the past. You expect dinosaurs. Instead, you land in a world far stranger and far more dangerous. No birds, no grass, no mammals as we know them. Just one massive supercontinent stretching across the globe, and creatures that look like experiments nature wasn't sure about yet. Welcome to the Permian period, and here's what would happen if you went there. A world called Pangea. Around 300 million years ago, Earth looked completely different. All the continents we know today, Africa, North America, Asia, Antarctica, were fused into one gigantic landmass called Pangea. Surrounding it was a vast global ocean known as Panthalassa. If you arrived during the early Permian, you'd notice something immediately. The air feels thinner. Oxygen levels were lower than today, possibly around 15% or even less in some regions, compared to our modern 21%. You could still breathe, but you'd feel winded faster. Climbing hills would feel like mild altitude sickness, and it would be cold. The Permian began at the tail end of an ice age. Large glaciers covered parts of the southern hemisphere. Average temperatures in some regions hovered around 4°C. Bring a jacket, but don't get too comfortable. Things are about to heat up. Fire and evolution. As the ice retreated, volcanic activity reshaped the planet. Massive eruptions pumped carbon dioxide into the atmosphere. Temperatures rose. Forests spread across Pangea, but these weren't forests like today. There were no flowering plants, no grass, no fruit trees. Instead, towering ancient plants dominated the land, including the first gymnosperms, seed-bearing plants that spread across the drying supercontinent. Their ability to reproduce without standing water gave them a massive, evolutionary advantage. Life was adapting fast, and so were the animals. The insect giants. If you look down, you might notice something unsettling. Cockroaches, but not the tiny ones you're used to. Some prehistoric insects were enormous compared to modern species. While Permian cockroaches weren't quite bird-sized everywhere, many insects in earlier periods had already reached shocking proportions due to fluctuating oxygen levels. You'd see giant beetles, early dragonfly-like insects, and strange multi-legged arthropods crawling through leaf litter. The ground would feel alive, but insects weren't the real rulers of this world. Something much bigger was watching you. Meet Dimetrodon, not a dinosaur. Out from the brush emerges a creature with a massive sail running down its back. It looks reptilian. It moves like a crocodile, but it's not a dinosaur. This is Dimetrodon. Living about 272 million years ago, Dimetrodon grew up to 5 meters long and weighed over 200 kilograms. Its iconic sail likely helped regulate body temperature, absorbing heat during the day and releasing it at night. And those teeth? A mix of sharp slicing fangs and crushing teeth designed for tearing through flesh. Dimetrodon was an apex predator. If you were standing there in the Permian, you'd quickly realize you are not at the top of the food chain. The rise of mammal-like reptiles. As the Permian progressed, another group began dominating, therapsids. These were early mammal-like reptiles, evolutionary stepping stones toward true mammals. Unlike earlier reptiles, their legs were positioned more directly under their bodies, giving them a more upright stance. This allowed more efficient movement and possibly better endurance. Some were herbivores, like Lystrosaurus, a stocky burrowing animal about 1 meter long that looked like a cross between a pig and a lizard. Others were predators, like Lycanops, equipped with sharp canine teeth and quick reflexes. These creatures were experimenting with traits that would later define mammals: differentiated teeth, possibly early fur, and higher metabolic rates. You are witnessing the deep evolutionary roots of humanity. The planet heats up. But something is changing. By the middle to late Permian, global temperatures begin rising dramatically. Average temperatures climb toward 25 to 28 degrees globally, extremely warm compared to earlier conditions. Why? Volcanoes. Massive volcanic systems begin releasing enormous amounts of greenhouse gases into the atmosphere. Sea levels fluctuate, climate zones shift. Pangea's interior becomes dry and desert-like. Forests shrink in some areas. Ecosystems become stressed. And the oceans? They're in trouble too. Life beneath the waves. If you swam in Panthalassa, you'd encounter ancient sharks, primitive bony fish, and bizarre marine invertebrates. Reefs built by sponges and algae dotted shallow waters. Early ammonoids drifted through the sea, but as temperatures climbed and oxygen levels dropped, marine ecosystems began destabilizing. Warmer water holds less dissolved oxygen, that means suffocation, and the oceans were about to lose their breath. The Great Dying about 252 million years ago, everything changed. Scientists call it the Permian-Triassic extinction event, or more dramatically, the Great Dying. Up to 95% of marine species vanished. Over 70% of land vertebrates disappeared. It was the worst mass extinction in Earth's history. The Siberian Traps. One of the leading theories involves a series of colossal volcanic eruptions in what is now Siberia. These eruptions lasted for hundreds of thousands of years. They released unimaginable amounts of carbon dioxide, methane, sulfur dioxide. The consequences were catastrophic. First, ash blocked sunlight, cooling the planet briefly. Then greenhouse gases trapped heat, sending global temperatures soaring. Oceans warmed rapidly. Methane hydrates may have been released from the seafloor, supercharging warming even further. Oxygen levels in both the atmosphere and oceans plummeted. Acid rain fell, marine ecosystems collapsed. On land, forests died, food chains disintegrated. It was a planetary reset. What would it feel like? If you were alive during the extinction, you'd notice thinner, harder to breathe air, oppressive heat, acidic rainfall, dying forests, rotting ecosystems, increasing wildfires. The sky might appear hazy from volcanic particles. Entire species would vanish within geological moments. It would feel like the planet itself had turned hostile. The survivors. Not everything died. Some resilient species endured. One of the most famous survivors was Lystrosaurus. This burrowing herbivore became incredibly abundant in the aftermath. Fossils suggest it dominated early Triassic ecosystems. Why did it survive? Possibly because it could burrow to escape extreme conditions, tolerated low oxygen, had a flexible diet. Evolution favors adaptability, and from this devastation, new life would rise, including, eventually, dinosaurs, and much later, us. Lessons from the Permian. The Permian extinction shows how interconnected Earth systems are. Climate shifts, volcanic activity, ocean chemistry, atmospheric composition. When one changes dramatically, everything else follows. It took millions of years for biodiversity to recover. The Earth survived, life survived, but almost everything alive at the time did not. If you stepped back into your time machine after witnessing the Permian period, you'd carry something profound with you. The knowledge that Earth is resilient, but also fragile. Entire ecosystems can collapse. Climate can shift rapidly. Mass extinction is not science fiction, it has happened before. And the Permian proved that when the planet changes fast enough, even dominant species can disappear. Would you dare explore that ancient world, or is it better left buried in stone? That's a story for another What If.